Hello everybody, my name is Shankarji. Now we'll discuss chapter 3, metals and non-metals. So first of all, what are metals and non-metals? Metals are substances that always give away electrons in chemical reactions. For example, iron, copper, aluminium, silver, gold, platinum, sodium, potassium, etc. Non-metals are substances which either gain electrons or share electrons in chemical reactions. For example, oxygen, nitrogen, carbon, chlorine, fluorine, hydrogen, bromine, iodine, etc. Now we'll discuss this topic, physical properties of metals. Metals usually have a shining surface which is called metallic luster. They are usually sonorous. That means they produce a striking sound when they are hit with an object. They are generally hard, they are malleable. That means they can be beaten into sheets. They are ductile, that means they can be drawn into wires. They are good conductors of heat and electricity. They have high melting points, etc. For example, silver and copper are the best conductors of heat. Similarly, another example is lead and mercury are poor conductors of heat. An important note, there are very few non-metals as compared to metals. Usually they are either solids or gases, except bromine, which is a liquid at room temperature. They have different physical properties than that of metals. Another important note, carbon is a non-metal that can exist in different forms. Each form is called an allotrope and this phenomenon is called allotropy. For example, diamond, graphite, etc. Now we'll discuss this topic, chemical properties of metals. Number 1, what happens when metals are burnt in air? The general format is metal plus oxygen gives metal oxide. For example, 2Cu plus O2 gives 2CuO, where Cu stands for copper, O2 stands for oxygen, and CuO stands for copper 2 oxide, or simply copper oxide. Another example is 4Al plus 3O2 gives 2Al2O3, where Al stands for aluminium, O2 stands for oxygen, and Al2O3 stands for aluminium oxide. Most metal oxides are insoluble in water, but some of these dissolve in water to form alkalis as well. For example, Na2O stands for sodium oxide, H2O stands for water, and NaOH stands for sodium hydroxide. Another example is K2O stands for potassium oxide, H2O stands for water, and KOH stands for potassium hydroxide. Number 2, what happens when metals react with water? The general format is metal plus water gives either metal oxide or metal hydroxide plus hydrogen. For example, 3Fe plus 4H2O gives Fe3O4 plus 4H2. Another example is 2K plus 2H2O gives 2KOH plus H2 plus heat energy. Number 3, what happens when metals react with acids? The general format is metal plus acid gives salt plus hydrogen. For example, zinc or zinc metal, H2SO4 stands for sulfuric acid, ZnSO4 or ZnSO4 stands for zinc sulfate, and H2 stands for hydrogen or hydrogen gas. Number 4, how do metals react with solutions of other metal salts? The general format is metal A plus salt solution of B gives salt solution of A plus metal B. For example, Fe plus CuSO4 gives FeSO4 plus Cu, where Fe stands for iron, CuSO4 stands for copper sulfate, FeSO4 stands for iron sulfate, and Cu stands for copper. Now we'll discuss this topic, the reactivity series of metals, or simply the reactivity series. It is a list of metals arranged in the order of their decreasing activities or reactivities. So we have the reactivity series as follows. Potassium is more reactive than sodium. In other words, potassium greater than sodium, greater than calcium, greater than magnesium, greater than aluminium, greater than zinc, greater than iron, greater than lead. Then we have the hydrogen barrier, which is a non-metal in between the reactivity series of metals, and then which is greater than copper, which is greater than mercury, which is greater than silver, and which is greater than gold finally. Now we'll discuss this topic. How do metals and non-metals react? All elements react to achieve stability in the form of noble gas configuration. That's why it's also known as or called as the stable noble gas configuration. We all know what noble gases are. Noble gases are the completely stable elements present or available or found in nature. These noble gases are helium, neon, argon, xenon, krypton and radon. These noble gases are the perfect elements because they are completely stable. So all elements, why do they react? Because they are not yet stable and they want to achieve stability. That's the reason why chemical reactions takes place. All elements react to achieve the stable noble gas configuration. This can be achieved when there are either 2 electrons, also known as the duplet, or 8 electrons, also known as the octet, in the outermost shell, also known as the valence shell of an atom of an element. So whenever an element gets either 2 electrons or 8 electrons in its outermost shell, also known as the valence shell, it achieves the stable noble gas configuration and it becomes completely stable, just like the noble gases. Metals give away electrons and form ions known as cations, and non-metals either gain or share electrons and form anions. So cations are positive in nature and anions are negative in nature. And cations are usually smaller than the parent atom and anions are larger than the parent atom. So in this way, generally metals and non-metals react with each other and they form ionic compounds which are very stable in nature. So what are these ionic compounds? Ionic compounds are compounds formed by the transfer of electrons from metals to non-metals. These ionic compounds are also known as electrovalent compounds. For example, sodium chloride NaCl, magnesium chloride MgCl2, etc. So we have the chemical equation in the form of Lewis dot structures as follows, where Na stands for sodium, Cl stands for chlorine, and NaCl stands for sodium chloride or the common salt. Similarly, let's take another example of magnesium chloride, where Mg stands for magnesium, Cl2 stands for chlorine, and MgCl2 stands for magnesium chloride, respectively. Now we'll discuss this topic, properties of ionic compounds. Number 1, physical nature. Ionic compounds are solids slightly hard because of the strong force of attraction between the positive and the negative ions. These ionic compounds are generally brittle and break into pieces when pressure is applied. Number 2, melting and boiling points. They have high melting and boiling points because a considerable amount of energy is required to break the strong inter-ionic attraction. Number 3, solubility. They are generally soluble in water and insoluble in solvents such as kerosene, petrol, etc. Number 4, conduction of electricity. They are good conductors of electricity in their molten or aqueous states because they release ions which move freely and conduct electricity in this state easily. Now we'll move further and discuss this topic, occurrence of metals. The Earth's crust is the major source of metals. Seawater also contains metal salts. The elements or compounds which occur naturally in the Earth's crust are known as minerals. An ore is a natural deposit containing a mineral of an element which can be extracted profitably. For example, bauxite, hematite, magnetite, copper pyrite, galena, etc. Now we'll discuss this topic, extraction of metals. Metals can be classified into three main categories, namely metals of high reactivity, metals of middle reactivity, and metals of low reactivity. For metals of high reactivity, electrolysis of molten ore is done and then the pure metal is extracted from the above mentioned electrolysis. For metals of middle or medium reactivity, two processes are followed, namely calcination and roasting, because normally the ores of these middle or medium reactive metals are found in the form of carbonates and sulfides in nature. For carbonate ores we follow calcination, and for sulfide ores we follow roasting. And after these processes we get the oxides of these metals, which are then reduced to their corresponding metals by following the process of reduction. And then further purification of metal is done by using various processes. The ores of the metals of low reactivity are normally found in the form of sulfides in nature. So these sulfide ores are first roasted by using the process of roasting. Then the metal or the pure metal is extracted from this process and then further refined accordingly by using various processes. Now we'll discuss this topic, enrichment of ores. Ores mined from the earth are usually contaminated with large amounts of impurities such as sand, soil, etc., called gangue. The impurities must be removed from the ores prior to the extraction of the metals. So different separation methods or techniques are employed accordingly. Now we'll discuss this topic, extracting metals low in the activity series. Usually the oxides of these metals can be reduced to their corresponding metals by heating. For example, cinnabar, which is HGS, is an ore of mercury, Hg. So we have 2HGS plus 3O2 upon heating gives 2HgO plus 2SO2. Further, 2HgO upon heating gives 2Hg plus O2. Similarly, we have for copper as follows: 2Cu2S plus 3O2 upon heating gives 2Cu2O plus 2SO2. And further we have 2Cu2O plus Cu2S upon heating gives 6Cu plus SO2. Now we'll discuss this topic, extracting metals in the middle of the activity series. The ores of these metals are normally present as sulfides and carbonates in nature. So roasting and calcination processes are used accordingly. Roasting is the process of heating the sulfide ores of metals with oxygen, and calcination is the process of heating the carbonate ores with oxygen respectively. For example, 2ZnS plus 3O2 upon heating gives 2ZnO plus 2SO2, and ZnCO3 upon heating gives ZnO plus CO2. The metal oxides are then reduced to the corresponding metals by using suitable reducing agents such as carbon. For example, ZnO plus C gives Zn plus CO, where ZnO stands for zinc oxide, C stands for carbon, Zn stands for zinc, and CO stands for carbon monoxide. Another example is 3MnO2 plus 4Al gives 3Mn plus Al2O3 plus heat. Another example is Fe2O3 plus 2Al gives 2Fe plus Al2O3 plus heat. This reaction is known as the Thermit reaction, and it is used to join railway tracks or cracked machine parts. Now we'll discuss this topic, extracting metals towards the top of the activity series. These metals are obtained by electrolytic reduction as they are very reactive, and they cannot be obtained from their compounds by heating with carbon. For example, sodium, magnesium, calcium, aluminium, etc. These metals are deposited at the cathode and the other products are liberated at the anode respectively. For example, sodium. The reactions are as follows. At cathode, Na plus E minus gives Na. At anode, 2Cl minus gives Cl2 plus 2E minus, where Na plus stands for sodium ion, Cl minus stands for chlorine ion, and E minus stands for electron respectively. Now we'll talk about refining of metals, and we will discuss this subtopic, electrolytic refining. Many metals such as copper, zinc, tin, nickel, silver, gold, etc. are refined electrolytically. In this process, the impure metal is made the anode and a thin strip of pure metal is made the cathode. A solution of the metal salt is used as an electrolyte. On passing the current, the pure metal is deposited at the cathode. The soluble impurities go into the solution, whereas the insoluble impurities settle down at the bottom of the anode and are known as anode mud. Now we'll talk about corrosion. So what do you mean by corrosion? It is the gradual destruction of metals when they react with air and water over a period of time. For example, rusting of iron, tarnishing of silver, etc. Now we'll discuss this topic, prevention of corrosion. There are many methods of preventing corrosion like painting, oiling, greasing, galvanizing, chrome plating, anodizing, making alloys, sacrificial protection, etc. Normally the metals are painted with a layer of chemicals in these methods like painting, oiling, greasing, etc. Grease is normally used as lubricants in various automobiles and machine parts as well. So what do you mean by galvanizing? Galvanizing means to cover iron or steel with a coating of the zinc metal to protect it from corrosion. What do you mean by anodizing? Anodizing means coating with a protective oxide layer by an electrolytic process in which the metal forms the anode. That's why this process is known as anodizing or simply called anodizing as well. Sacrificial protection is the protection of iron or steel against corrosion by using a more reactive metal, which corrodes and thereby protects the other metal from getting corroded. So in this way we have discussed this chapter 3, metals and non-metals, and you can also do some Google search and add some additional information to the existing knowledge which we have. And if you have any doubts or suggestions, you can let us know in the comment section below.